Okay, hi everybody. So we're going to talk about chapter 3 in this video lecture today. The first topic we want to do in this chapter is measures of center. So measures of center is just talking about how do we measure the center of data. We have several ways to measure the center of data. In particular, we want to talk about mean, median, and a mode. But what we want to know is which measurement to pick and what's the interpretation of these values. So the first thing is talk about a measure of center. Basically, this topic talks about a value at the center or in the middle of a data set. So there is some difference between at the center or the middle of the data set. Okay. And we see some of the interesting ideas coming up. So first thing is talk about the mean. Mean is actually an idea that you've been using quite a lot. Take a look at the definition and we'll talk about the mean in just a minute. So the mean is basically adding all of the data values and then simply dividing the total by the number of data values. This is similar to, so something like the average that we have done in the past. So mean, some important property of the mean. Mean is basically tends to vary less than other measures of center, and the mean uses every data value. Okay, so it uses every individual data value because we need to find the sum. However, mean is not resistant to extreme values, which means extreme values may change the mean value somehow. By the way, the extreme values we'll be using later is called outlier. Okay, so be familiar with the outlier. Extreme value is called outlier. Over here we have some notations that is important for you to do throughout the semester. Okay. First of all, let's talk about sigma symbol. Sigma symbol basically talks about the sum. Okay. Sigma is sum. While the X typically just talk about those individual data values. And n, lowercase n, represents the number of data values in a sample, which is also called sample size, how big a sample is. Capitalized N represents population size. Now, it's worth noting that you can see that for sample, use lowercase n for sample size. For capitalized N, it's used for population. So this is, again, sample statistic versus population parameter. Okay. These two, they use different notations, and we should be, in particular, be careful about the notation symbols here. Alright, so now let's introduce the notation for the mean. Okay, so again, we have two types of mean. One is called sample mean, one is population mean. For sample mean, sample mean, it is X bar. Okay. X bar is sample mean. Population mean is mu. So let's use this one here. Sample mean and population mean is mu. Okay, X bar is basically the sum of all the X values, all the data value, and then divided by sample size, as we just mentioned. While mu means it's the sum of individual data value and then divided by the population size. And different notations have different meanings. Here again, you see the N is for sample size and capitalized N is for population size. Okay. So I'll put here sample mean, and this is population mean. However, for the way we compute it, it's the same. Basically, you sum all the data values and simply divide by the number of data values you see. Alright, so we're going to look at some examples here. First example, let's find a sample mean. Okay, this is from airport data speeds. includes measures of data speeds of smartphones from 4 different carriers. Okay. Finds the mean of the first 5 data speeds for Verizon: 38.5, 55.6, 22.4, 14.1, and 23.1. So they are in megabytes per second. These are from samples, so we use the symbol for sample mean here. Okay. So you just add all those data values up and then just divide by 5. We got 153.7. Divide by 5, we got 30.74 megabytes per second. And notice that here we have 2 decimal places compared to the original data. Original data has only 1 decimal place. Okay. And we'll be explaining why this is the case. So 1 decimal places versus the result. In our case, we have 2 decimal places. Now, some question for the term of average. Okay, although this is how we computed the mean, but for statistics, we don't call it to be average because average is sometimes too vague. So term average is not used by statisticians, and average is not used by journals as well. Okay. Not used by journals, research papers. Okay, next measure of center is called median. Okay, let's look at the definition of median. So median of the data set. So median of the data set is basically the middle value when the original data values are arranged in order of increasing or decreasing fashion. This one we can also say it's in sorted data set, or it's ordered data set. So basically, you need to sort those original data values either increasing or decreasing way, and the median will be the middle value when the data set has been sorted. Now, some important properties. Median is resistant measure of center, which means median will not be affected by extreme values. Okay. And a median does not directly use every data value. It basically uses the middle one or the middle 2. Okay. That is convenient, but sometimes it's also the advantage. I mean, the disadvantage of median as a measure of center. So let's look at the following example. Find the median of the first 5 data speed for the Verizon. The same data set. Okay. In this case, first of all, we need to check if this data set has been sorted, okay, or ordered. So this is not ordered yet, because we have small one, big one, small one, and relatively big one. Okay. So the first thing we need to do is sort these out in this particular way. So you see this is the low value and the high value. So from low to high. Okay. So we have low value to high value. So the value in the right middle, 23.1, is going to be our median. Okay, 23.1 is the median in this case. Now, if we add one more data, suppose we have 6 data values and 38.5 up until 24.5. This time, let's see how do we compute the median. First thing we need to do is still sort the data value from either the lowest to highest. So do lowest to highest. And the median is sort of in the middle, right? Because we don't have one particular one in the right middle. So in between 23.1 and 24.5. And therefore, what we need to do is just take out these two, 23.1, 24.5, and find the mean of these two, or we just try to average these two. Get 47.6, which is 23.80 megabytes. Okay. And again, this time you notice that in the raw data, there is only 1 decimal place, and in our final answer, we have 2 decimal places. And later on, we'll be talking about when how many decimal places we should save. Okay. All right, next is the mode. For mode, it's easy to identify. Mode is basically the value that occurs with the greatest frequency. In other words, this is the value that occurs most often. Right here. Occurs most often. That's called a mode. One important property for mode is mode can be found with qualitative data. For qualitative data, categorical data, mode can be quite useful. Okay. Sometimes the data set can have no mode, or one mode, or two modes, or multiple modes. Okay. It depends on the data set that you are given. Now let's see some of the special cases. If you have two modes, then it's called bimodal. Okay. If you got more than two modes, then it's called multimodal. When no value can be repeated, then we say it's no mode. So this is the example of sprint data speed. Let's suppose we have 0.2, 0.3, 0.3, to 1.2. In this case, 0.3 has occurred 3 times most often, so the mode will be 0.3 megabytes. Let's change the value just a little bit. Suppose you got 0.3, 0.3, 0.6, 4.0, and 4.0. Then you can see that 0.3, 0.3 and 4.00, 4.0, these two numbers have both occurred 2 times. They are the two modes, so it's called bimodal. Okay. And if you change the data value even more, suppose none of the data value actually repeated, then no mode. Very easy to identify. Okay, so now let's get into the round-off rules for measures of standard, which is something that we have already touched for the past several examples. For mean and a median, we carry one more decimal place than what is presented in the original data set. For the mode, leave the value as it is without rounding, so we don't need to do any rounding for mode. And that is why in the previous examples, let's look at some of the previous examples, like this one over here. The very original data set, each data value has only one decimal place, and our median carries 2 decimal places, one more decimal place than what's appeared in the original data set. Okay. However, you don't need to do this for mode. For mode, you just take what those original data is. So you don't need to worry about the rounding for modes. Okay, next we want to talk about calculating in StatCrunch. In this course, you guys are not requested to use calculators. Instead, we're going to be using one tool that is embedded in your MyStatLab. So we're going to use the StatCrunch instead of calculator. And the way you get StatCrunch is very simple. Just go to MyStatLab. Okay. This is MyStatLab, and on the left you should see StatCrunch. So this is the MyStatLab. If you look at the left-hand side, you have these choices. And if you click StatCrunch, it's going to take you to this page, and you can just hit StatCrunch website. Okay, and that's where we will be going for computations. You can have a lot of choices for how you enter your data. If you're just typing the data into a data table, then just hit this choice, and that will take you this page. Alright, we're going to continue from the next video to see how we can do the median and a mode and a mean in StatCrunch.